Welcome to Intelligent Membrane CPD Advanced Technology for Achieving Airtightness. We explore the benefits of liquid-applied airtight membranes, how they can be used by main developers, house builders, and contractors to achieve better airtightness performance, which will allow you to provide superior comfort for occupants and users. Current solutions and technologies for achieving airtightness, and a balanced overview of their pros and cons. Throughout this presentation, we will be making reference to our liquid-applied airtight vapor control coating and how it's revolutionizing the way professionals within construction deliver safe, effective, and sustainable outcomes. We hope you come away with a fresh perspective and an improved understanding of liquid-applied airtight membranes. We'll begin by outlining the key objectives and success criteria. We will learn more about liquid-applied airtight vapor control membranes and their benefits, and to understand the airtightness technologies available. By the end of the session, we hope you will understand the different solutions that are available for achieving airtightness, gain more understanding of the latest regulations around airtightness, and gain more clarity on what makes a liquid-applied membrane effective. We'll address these learning objectives at the end of the session. We recommend making a note of these objectives to use as reference points throughout. Before we begin, a little bit about intelligent membranes. Intelligent Membranes manufactures and supplies high-performance, liquid-applied construction materials. With 22 years' experience, we have been creating innovative liquid technology for the construction industry for more than 2 decades. You will see our products in many buildings across the world, with hundreds of main developers, house builders, and contractors benefiting from our innovative solutions. We champion passive house standards and strongly believe that this methodology should be accessible to all buildings. Achieving airtight buildings and high levels of insulation is what we feel passionately about. In doing so, we are helping to achieve more sustainable outcomes for all building projects. Climate change is undoubtedly the greatest challenge of our time. Science is now showing with alarming clarity how quickly we are running out of time to avoid catastrophic and irreversible changes to the world around us. The Energy Independence and Security Act of 2007 set the stage for the U.S. to improve energy efficiency and reduce greenhouse gas emissions through enhanced use of renewables, nuclear, and carbon capture technologies. Alongside state-level actions, this legislation aims to significantly lower the country's carbon footprint, contributing to global sustainability and environmental goals. However, what is expected and what is achievable are two different things. Quite often, changes in building design and improvements in fabric all have significant cost implications. Here at Intelligent Membranes, we believe that superior effective airtightness should be accessible for all buildings. If we seek the definition of approved documentation, then Approved Document F ventilation defines airtightness as a general descriptive term for the resistance of the building envelope to infiltration with ventilators closed. The greater the airtightness at a given pressure difference across the envelope, the lower the infiltration. Airtightness is the fundamental building property that impacts infiltration and exfiltration. The uncontrolled inward and outward leakage of outdoor air through cracks, interspecies, or other unintentional openings of a building caused by pressure effects of the wind and/or stack effect. As you can see from the image, air leakage can occur in multiple places throughout the average household. For example, junctions between walls and other walls or floors, junctions between window frames and walls, electrical equipment and access doors and other wall penetrations. The orange arrows represent air leaking out of the house, whilst the blue and purple arrows demonstrate air leaking into the house. An airtight building means an energy-efficient building. Because the mixing of indoor and outdoor air is limited, users will benefit from reduced energy bills from heating and cooling. Energy Star, a government-backed program which provides certification to buildings and consumer products which meets certain standards of energy efficiency, has conducted research on commercial buildings and found that a property can waste as much as 30% of their energy usage due to airtight issues. By making small upgrades, the energy efficiency of a building can increase by 10%. Having an airtight building has many benefits. These include lower running costs through reduced heat loss, improved comfort, improvement in energy efficiency within the heat recovery ventilation systems, improvement within the energy efficiency of the entire building, and reduction in moisture infiltration levels. The International Energy Conservation Code, IECC, alongside local codes, mandates airtight construction for new dwellings in the U.S. air tightness testing, aligned with stricter IECC versions, is a standard for new constructions, requiring a specified percentage of homes within a development to be tested. This selection includes varied building layouts, such as detached versus semi-detached homes or multi-story units. The regulations aim at energy consumption reduction, specifying that buildings undergo air tightness testing through the blower-door method per ASTM E779. This involves building pressurization and thermal imaging to detect leaks, setting forth maximum air leakage rates with a best practice goal to surpass these minimum standards for enhanced energy performance. Industry discussions suggest updates like pulse testing could refine testing accuracy and compliance stringency, highlighting the importance of evolving standards for energy conservation. Next, U.S. ventilation and energy efficiency guidelines will be examined. In 2002, the U.S. adopted measures under the International Energy Conservation Code, IECC, to enforce building air tightness standards, aiming to reduce energy costs, ensure material and workmanship quality, eliminate drafts, and prevent condensation issues. Compliance is verified through air permeability and blower door tests, quantifying air leakage per hour per square meter at a specific pressure differential. In residential settings, maintaining indoor air quality involves controlled ventilation across the property. Utilizing extract ventilation in high humidity or pollution areas, like kitchens, and ensuring the capacity for purge ventilation, essentially the ability to open windows for fresh air. For commercial spaces, the focus is on continuous clean air circulation, achievable through easily maintainable air conditioning systems to reduce airborne illness or allergen risks. The IECC mandates a collaborative approach to air tightness, with designers, site managers, and construction workers all bearing responsibility for implementing and maintaining these standards to achieve energy-efficient, airtight buildings. The following slides will focus on what solutions are available and currently being used to achieve airtightness. Traditional methods of airtightness include the use of silicone, paper, and adhesive tapes. These are all readily available in the market and commonly used throughout the construction industry in new dwellings. Despite their respective popularity, these more traditional methods are not without their faults. We will now aim to address the pros and cons of these methods. The popularity of silicone paper and tape applications could be due to a number of factors as highlighted in this table. For instance, paper and tape have no drying time. However, it's important to note that whilst this may appear to speed up the application process, all methods will require multiple applications in order for it to produce positive results. This may turn out to be a lot more time-consuming in the long run and more labor-intensive. In order for professionals like you to support the U.S. goals for sustainable and energy-efficient housing, we believe that a solution emphasizing ease of application, safety, and sustainability is essential in today's construction industry. Liquid-applied membranes. More businesses, organizations, and users are turning to liquid-applied airtight vapor control membranes. We refer to them as next generation due to their high performance properties and significant green credentials, helping professionals achieve safer, sustainable outcomes for their clients. We will now outline the scientific characteristics of liquid-applied membranes and why this revolutionary air tightness solution is gaining more and more popularity within the construction industry. A lesson in science. How do liquid-applied membranes work? A liquid-applied membrane LSDM is a fully bonded liquid-based coating. Due to its many benefits, which we will outline shortly, you will find this coating being successfully used for a range of construction applications, The coating cures to form a rubber-like elastomeric membrane and may be applied over many substrates, including blockwork, timber geoboard, foam block, woodcrete spray applied foams, and concrete. We will now explore external and internal use of liquid-applied membranes. This picture demonstrates the use of a liquid-applied membrane on the external facade of a building. As it's a vapor control, this liquid-applied membrane should only be applied to the warm side of the insulation. If applied to the facade, the user should insulate over it, for example, in a retrospect term. We will explore this further in our case study later on in the session. It can be applied in any direction by an airless spray device, brush, or roller, and can be used on masonry, brick, timber frame, wood, crete, and foam block. Please note that when using any application device, appropriate measures should be taken. This includes the correct use of PPE, including gloves, goggles and overalls, and respiratory protective equipment, RPE. When specifying a liquid-applied membrane, look out for VOC-free. Products that are VOC-free don't contain any volatile organic compounds in them. Nonetheless, protective measures should always be taken to ensure safety to the user. Internal use of liquid-applied membranes. Air leakage paths, which are commonly found in dwellings, can be easily controlled through the internal use of a liquid-applied membrane, LOM. This particular membrane can be applied in any direction by an airless spray device, brush, or roller. It can be applied onto blockwork timber frame, SIPS joints, ceilings, door and window joists, floor and wall connections, pipe penetrations, and more. Please note the techniques of minimizing joints or using inherently impermeable materials, like concrete or sheets panels such as ply, OSB, or CLT, are fundamental to an approach to designing and specifying for airtightness. As previously mentioned, always ensure you use appropriate PPE when using any liquid-applied membrane product. Why liquid-applied membranes? This advanced technology is revolutionizing the way builders achieve airtightness, and this table demonstrates some of the many benefits that a liquid-applied membrane will have within your application. The client and user will save time and money whilst having the best performing product the market has to offer. It doesn't hide the problem, it becomes part of the fabric itself. Ease of use, easy application in the most challenging of locations and objects. It doesn't deteriorate over time, meaning that airtightness will maintain its longevity, super fast application with either a brush or spray extremely durable. After it dries, it turns into a hardened polymer, which has a lifetime guarantee of airtightness. No continuously searching and repairing for paper rips and tears. Some liquid-applied membranes move with the building settlement and substrate movement, and do not shrink or deteriorate over time, offering a full, complete airtight seal for as long as the building stands. It's also Passive House certified. Please note, however, that you should always seek fire rating certification when specifying a liquid-applied membrane as defined in Approved Document B. It's crucial that any component of an external or internal wall construction should address the issue of combustibility. At Intelligent Membranes, our liquid-applied membrane has undergone rigorous fire safety testing in accordance with U.S. standards, such as those set by NFPA, National Fire Protection Association, or ASTM International. It meets or exceeds the necessary criteria for fire resistance, ensuring compliance with U.S. regulations for building materials used in structures of all heights. Liquid-applied membranes. Technical benefits. From a technical perspective, we'd like to take this opportunity to highlight some of the main technical benefits that our liquid-applied membrane has to offer. As previously stated, it is Passive House certified, which is said to be one of the most carbon-friendly construction methodologies in the world today. Very low air leakage rates are required by the Passive House standard and must be demonstrated for each certified building by means of a blower door air tightness test. The air change rate must be less than or equal to 0.6 air changes per hour under test conditions. It also meets stringent industry standards similar to those recognized by organizations such as ASTM International in the U.S. Our liquid-applied membrane adheres to the rigorous quality and performance metrics equivalent to U.S. standards for liquid airtight vapor control layers. It is a radon barrier. Inside a building, people inhale tiny particles of radon, which then irradiated the lining of the lungs. Radon can cause lung cancer, and it poses a particular threat to children smokers and ex-smokers. This odorless gas is the second leading cause of lung cancer after smoking. A single installer can apply up to 300 square meters of passive purple a day using an airless spray device. This speeds up the construction time and cuts labor costs dramatically. It is M1 class, which is the emission classification of building materials. Materials that are M1 class are outlow emitting, so that material emissions do not increase the requirements for ventilation. VOC-free. It is a water-based product, which means no nasty chemicals, and it's friendly for the user and the environment. Volatile organic compounds. VOCs are organic chemicals that have a high vapor pressure at ordinary room temperature. Some VOCs are dangerous to human health or cause harm to the environment. Many airtightness solutions contain harmful VOCs due to their ease of use in application. So a product that doesn't have any VOCs will have better outcomes for you, the installer, and the end user. Finally, this liquid-applied membrane can guarantee you a score of 0.6 HH air changes per hour and under as tested by the Passive House Institute with an airtight score of 0.03 HH. That's 20 times under the required 0.6 HH needed. We'll now take a look at two examples of where liquid membranes have been used for airtightness. Case Study 1. Our first case study comes from an apartment block in Great Yarmouth. With people still inhabiting the building, the installers needed to overcome a multitude of challenges to achieve maximum results. This liquid-applied membrane was used as an air tightness membrane sprayed to the outer face of the original walls. Brackets were then fitted which created a void for the eco-bead insulation. The walls were finished with bag ply board, a frame tight with a membrane battens, and a steady pre-finished render board with a textured finish. The apartments were being improved from SAP EPC ratings of D and C. Case Study 2. Our next case study comes from a passive build based in Cambridge. Here you will see the results of when our liquid-applied membrane brush is used to seal all connections of a variety of substrates from steel to timber, and finished with the spray application. Reflecting back to the start of this CPD and the learning outcomes that were set out, you should now have a clear understanding of the different solutions available for achieving airtightness, the latest regulations around airtightness, and the revolutionary benefits a liquid-applied membrane can have. We hope you've enjoyed our CPD on advanced technology for airtightness, and we hope that this new knowledge will help you to achieve improved outcomes for you and your clients. If you'd like any more information on our new liquid-applied membrane application, you can contact one of our experts using the details on screen now. Thank you for watching.